talking about writing linear equations from tables and points. We've done this a little bit, but we're really going to focus in on it today as we kind of keep building up that skill of writing a linear equation. Okay, so I want to write a linear equation that goes to the points 1, 4 and 6, 14. So right now, just as a reminder, our linear equation is y equals mx plus b. So I don't have m, my slope, and I don't have b, my y-intercept. And my y-intercept is not one of my 2 points. So I'm going to have to do a little bit of extra work here. Okay, but first step always is I need to find my slope. Okay, so remember we find our slope by lining up our 2 points. First point on top, second point on bottom. Then we find the change in x, which from 1 to 6 would be plus 5. And the change in y, which from 4 to 14 would be plus 10. Which would make our slope change in y over change in x, 10 over 5, which is equal to 2. Okay? So far my equation, I have y is equal to, I can replace m with 2, 2x plus b. Okay? Now I still need to solve for b. And right now, with the equation I have written, I have 3 unknowns. I don't know y, I don't know x, and I don't know b. Okay? If I wanted to solve for b, I could plug in so I don't have quite as many unknowns. So what I can do is I can take one of my points. It doesn't matter which one. I typically choose the one with smaller numbers because it's easier to work with. So I'm going to pick 1, 4. And we would take the x value and plug it in for x, and the y value and plug it in for y. So this is going to become 4 is equal to 2 times 1 plus b. Okay, so I replaced my x value of 1 here and my y value of 4 there. Okay, so 4 is equal to 2 times 1 is just 2, so 4 is equal to 2 plus b. And then just like any other solving an equation, I'm going to move over what's next to b. So minus 2, and we get 2 is equal to b. So as our final answer, I can go back to that original equation and replace b with what I now know it to be. And that is writing a linear equation given 2 points. So it's always going to repeat that same process. Solve for the slope first. Then once you solve for the slope, you're going to plug in one of your points to solve for b. Okay, let's practice it. So number 2, we have negative 2, 5 and negative 6, 7. So I'm going to line up my 2 points. So negative 2, 5 over negative 6, 7. To go from negative 2 to negative 6 would be minus 4. And to go from 5 to 7 would be plus 2. So m would be equal to 2 over negative 4, which would be equal to negative 1/2. So I can then write my equation, y is equal to negative 1/2 x plus b. Okay, so I still have my 3 unknowns. I want to solve for b, so I'm going to take one of my points. Doesn't really matter which one, but I typically just choose the first one. Plug x in for x, plug y in for y. Okay, so 5 is equal to negative 1/2 times negative 2 plus b. Okay, now you can always plug this into your calculator. I need to do negative 1/2 times negative 2. Okay, but we also know that a negative times a negative, those negatives are going to cancel out. 1 over 2 times 2 over 1. The 2 and the 2 are going to cancel out. So we are left with just 1. So 5 is equal to 1 plus b minus 1, and we get 4 is equal to b. So for our final equation, y is equal to negative 1/2 x plus 4. And this is going to take some practice, y'all. So take your time, use your calculator if you need to, so that you can be successful with these. Let's practice one more with the 2 points. So write a linear equation that goes through the points 3, 5 and negative 2, 20. So same thing, line up my 2 points. So 3, 5 and negative 2 comma 20. To get from 3 to negative 2, that would be minus 5. To get from 5 to 20, that would be plus 15. So m is equal to change in y over change in x, 15 over negative 5, which would be equal to negative 3 for our slope. So y is equal to negative 3 x plus b. Then once again, I take one of my points. X is going to go in for x. Y is going to go in for y. So 5. 5 is equal to negative 3 times 3 plus b. Negative 3 times 3 is equal to negative 9. So 5 is equal to negative 9 plus b. Plus 9 plus 9, and we get 14 is equal to b. So for our final equation, y is equal to negative 3x plus 14. Hey, nothing too crazy, y'all. Hey, now our second set is writing a linear equation from a table. So one thing to keep in mind about a table is that a table is really just like 2 points, but it's like a whole bunch of points all listed up in a row. Okay, so if I have a table, the one below, negative 2, 2, 6, and 10, and then the y values 1, 2, 3, and 4. Okay, just like we've done before, we still want to find our slope, but they've already lined up the points for us, so we can just find that change in x. So change in x would be plus 4 each time. Change in y would be plus 1 each time. So m would be equal to change in y over change in x, which would just be 1/4. So from there, y is equal to 1/4 x plus b. Okay, so now, just like with 2 points, our table is just a bunch of points. You can pick any point from the table to plug into your equation. I typically try to pick points that are going to keep things nice and positive. So like the nice and easiest point I can see will be this one right in the middle, 2 comma 2. It doesn't matter which point you pick. Any point should work to give you b. So both of our numbers are 2, so I can plug 2 in both spots. So 2 is equal to 1/4 times 2 plus b. So 2 is equal to 2/4 plus b, which means 2 is equal to 1/2 plus b. Okay, and then I can subtract 1/2 from both sides, so minus 1/2 minus 1/2. 2 minus 1/2 would give us 3/2, just in case you need that work a little bit better. So 2 minus 1/2. This is the same as 2/1, which I can multiply by 2, multiply it by 2. This is the same as 4/2 minus 1/2, which would give us 3/2. So 3/2 is equal to b, which gives us our final bit for our equation. Y is equal to 1/4 x plus 3/2. Hey, so same sort of deal. Find your slope, plug slope into the equation, then you're plugging in both points. Let's look at another one. So write a linear equation that models the data below. So 3 to 0 is plus 3. 0 negative 3, or sorry, not plus 3, minus 3. Mr. Arbone's being crazy this morning. Then minus 3. Negative 3 to negative 6 is minus 3. Negative 5 to negative 7 is minus 2. Minus 2, minus 2. So our slope would be equal to negative 2 over negative 3, which would give us a slope of positive 2/3. So for our equation, we get y is equal to 2/3 x plus b. So then I would plug in a point. Doesn't really matter which one. They're all kind of gross with negatives and that sort of stuff. But one thing you might notice, you're actually given the y-intercept in this one. So I don't actually need to plug in a point because I already know when x is equal to 0, y is equal to -7. So I can go straight to that. Y is equal to 2/3 x minus 7. So sometimes one of the points you're given, either in your 2 points or your table, might just be your y-intercept and make your life a little bit easier. Okay, let's do one last one together, y'all. So we're writing a linear equation that models the data in the table below. So 4 to 5 is +1, 5 to 6 is +1, 6 to 7 is +1, 0 to 4 is +4, 4 to 8 is +4, 8 to 12 is +4. So slope is equal to 4 over 1, so slope is equal to 4. So we get y is equal to 4x plus b. Okay, once again, we need to plug something in. So I would pick the very first point, 4, 0. So this one, notice this time y is 0, x is 4. So this is not our y-intercept. This would actually be our x-intercept. So we're going to still need to plug it in to solve for b, our y-intercept. So then we plug that point in. So y would be equal to 0, 4 times 4 for x plus b. Okay, 0 is equal to 4 times 4 is positive 16. Plus b minus 16 minus 16. 0 minus 16 would be equal to -16 is equal to b. So y is equal to 4x minus 16, just like so. And so, y'all, that is writing linear equations from 2 points or from a table.